Hello. So in this video, I wanted to recap what we should know about power series. Okay, so power series are more or less a framework of viewing any function as a polynomial. So a power series, we'll call it p of x, is equal to the sum n equals 0 to infinity of c sub n x minus a to the n, and this is a power series centered at a. Okay, and I usually say x equals a. Okay, so a power series looks like this. So the first few terms of your power series are going to look like this. So we have c0 plus c1 times x minus a plus c2 times x minus a squared, so on and so forth. Okay, so the typical question you'll be asked about power series is you'll be asked to find the interval and radius of convergence. Okay, to do this, you're going to use one of two techniques. Because you have that x minus a to the n, if c sub n is a constant, we then have a geometric series. The other way we'll do this is via the ratio test. Okay, and note with the ratio test, then we may have to check endpoints. Okay, so if at the end of the day you get absolute value x minus a is less than some value r, that's your radius of convergence. Okay, so that's after applying the ratio test or the geometric series test. Uh, Then if you used ratio test, you may have to check the endpoints, in which case your interval of convergence is always uh, x minus a less than r and bigger than minus r. Add a to everything, so minus r is minus r plus a is less than x is less than r plus a. Okay, so in order to check these endpoints here, to see whether or not you have equality at either side, you would plug in x equals negative r plus a and x equals r plus a into your original power series. If it converges, you include the equality. If it doesn't, you don't. One other thing to mention about power series is we can find the power series of the derivative. So p prime of x is just going to be the term by term power series, the term by term derivative. So we can take the derivative of this with respect to x. So this would be the sum n equals 0 to infinity of n times c sub n x minus a to the n minus 1. And seeing that n equals 0, this term goes away. We can change this ever so slightly. We can do that. Nope, I erased the wrong thing. So if I go over here, we can really start at n equals 1 then. Okay, alternatively, we can also find the indefinite integral of p of x just by taking the term-by-term antiderivative. Nailed that one. Okay, so we take the term-by-term antiderivative, so this is going to be the sum. N equals 0 to infinity of c sub n over n plus 1 times x minus a to the n plus 1, and then you may have a plus a constant at the end that you can solve for.